All right. Welcome, everybody. My name is Jody Kirk. This is STG208, Backup and Restore and Disaster Recovery Solutions with AWS. Thank you for all joining us today. Welcome to reInvent 2019. I'm here with two of our esteemed customers, and with Creighton Swank, who is a cloud architect for Caterpillar, as well as Juan Mejia, who's the data center manager for Bank United. Juan and Creighton are going to share with you their stories, how they've been able to leverage the AWS cloud to support their backup and disaster recovery initiatives for their respective organizations. So let's jump into the overview for today. First, we're going to talk just a little bit about why we protect data in the first place, just to lay a little bit of groundwork. We're going to talk about modernizing your backup using the cloud and some approaches that you can take in order to do that. We're going to talk about some common backup patterns. So this is both how customers are using native AWS services to perform backups, as well as our partner ISV backup partners and some of the architectures that those ISVs support, and how customers are deploying those solutions for their backup. Then we're going to talk a little bit more specifically about disaster recovery approaches. So let's start off by laying a little bit of the groundwork. Like, why do we back up data in the first place? We back up data to ensure the safety and security of the information we store. But in reality, the reason we do it is because we don't want to lose it, right? And so because we don't want to lose it, lost data can have impact on our business, can affect our brand, can affect trust in our customer relationships, can affect future and current revenue streams as a result. And so when you look across your business applications, you realize that some applications are simply more important than others to your business. So in order to ensure that those applications are protected effectively, we try to understand how much data we can afford to lose as an organization for those applications. And so that decision, the recovery point objective for those applications, or how much data we have to lose, will dictate the frequency in which we take backups, and it will also have cascading effects in terms of the decisions we make of the systems and services that we're using in order to support those applications. Second thing we look at is how long does it take to recover, the recovery time objective. This is a function of how much your business can tolerate to have applications and its associated information offline. In some cases, an hour of downtime for some businesses can be in the millions of dollars, right? So the recovery time objective is the second critical aspect of defining your backup and disaster recovery strategies. So the question is, why don't we just back up everything forever using techniques like continuous data protection, point-in-time recovery? If we backed up every application forever so we could scale back to any point in time in the past and restore to that specific point in time, that would be kind of nirvana, right? Well, the reason we don't do that is because we don't need to. Different applications have different levels of importance to your organization, and therefore doing so would be, backing up everything forever would be overkill. So what we do is we try to create a balance between cost and liability or risk associated with not backing up applications. So how do we create that balance? The first step is to go through the process of determining how important your various applications are. We do this through a business impact analysis. The business impact analysis is designed to help an organization understand the cost associated with downtime. So that cost associated with downtime will help you set your RPO and your RTO requirements for your business. And then once you develop those RPO and RTO requirements, then you can have the discussion with your finance teams, their ability to fund it, right? So that's where the balance comes in, the funding ability with the requirements that you're required for your applications. So now that you've got your requirements established, there may also be some compliance considerations. So for example, if you are required for compliance purposes to have a copy of your data over 150 miles from your primary data set, that might be a consideration that affects your overall strategy. But these requirements are the foundation for how you go about determining your effective backup and disaster recovery strategies. All right, so now you've got options for where to store your backups. Why should you consider the cloud in the first place? So first, let's take a look back at the traditional backup environment. In the traditional backup environment where backups were done on premises, you've got application servers, you've got media servers that are making copies of the application data, backing them up to tape, or if there's a lower RPO, probably to disk. And then some copies of those backups are stored typically off-site for longer-term compliance, using a third-party data bunker service to get those off-site. What we've heard from customers is that there's a whole lot of undifferentiated heavy lifting in that process. The process of managing the tape arrays, the process of managing the third-party vendors to get that data off-site. And the cloud provides some compelling options for streamlining that overall process. So why is moving to the cloud so common for backups? One of the reasons is because it's the infrastructure that you've already put in place to manage on-premises backups can be utilized to support your cloud backups, right? We can support utilizing your existing backup applications and your existing backup workflows with little modifications. Instead of pointing to a disk-based target on premises, you're now pointing to a cloud-based target in Amazon S3, for example. Very little modification to your backup workflows. Additionally, you get cost-effective off-site storage alternatives. So you get separation of your backup data from your primary data with no initial upfront investment, pay-as-you-go pricing. So it's very cost-effective in terms of getting started. Another reason is backup presents a discrete workload. It's not an active workload, meaning there's no application depending on it at that point in time. So it's easier to do POCs, trial, getting those workloads into the cloud. And then if you're running tape, just the elimination of the tape infrastructure for getting rid of that infrastructure, it's prone to failure, typically high support costs, so customers are more than happy in most instances to find a better way to manage that function. And then if you're doing any kind of analytics or you want to gain better insights from your data, having the data in the cloud allows you to have access to other services from AWS to support analytics and understanding that data, or to provision a copy of that data so you can have, for example, a test and dev team do some extra work on experimenting with that backup data. So the first question customers ask is, will my data be safe? So Amazon S3 and Glacier are designed for 11 nines of durability. Those are the two primary services that customers are using to back up their data to the AWS cloud. So what does 11 nines of durability really mean? It means that if you have 10 million objects stored in Amazon S3, over 10,000 years, on average, you will lose one object. So that's highly durable, highly durable. Your data is safe in the AWS cloud. And when you think about the AWS cloud, we've got 22 regions that are online today around the world. We've got 3 additional announced. And when we think about regions, our regions are built of multiple availability zones, and each availability zone has multiple data centers within that availability zone. So some of our cloud competitors talk about having in excess of 50 regions, when in actuality, they consider a region a single data center, not a single data center or multiple data centers within an availability zone or multiple availability zones within a region. Just a single data center constitutes a region for our competitors. So it's really apples and oranges comparison. In addition, each region has two transit centers that are fully independent and redundant that allow traffic to cross the AWS network, enabling AWS regions to connect to the global network. So there's full redundancy and access to your data as well, based on the design that we have. And then if your business requires compliance, we provide more flexibility and capabilities to ensure that you're able to meet those compliance objectives. So for example, with S3, you can replicate your data cross-region from any S3 service, including S3 Glacier. So for example, if you have your primary bucket in S3, you can make a replica copy of that in a secondary region in S3 Glacier. Save you money on that secondary copy. You can replicate from any region to any region. You can replicate at the bucket level. You can replicate at the prefix level. You can replicate at the object level. You can even replicate within a region now. We just supported that just a quarter ago. So you can actually replicate within a region if your requirements dictate that. So lots and lots of flexibility in terms of being able to achieve compliance with the AWS architecture. All right, so now that we've covered why we back up and why backup to the cloud makes sense, let's discuss some common backup patterns that we see our customers deploy. So first I want to cover some of the AWS services that are commonly used and some of the ways that customers are utilizing those services for their backup activities. So the first one is backups to using the file gateway. So the AWS storage gateway comes in 3 variants: a file gateway, a volume gateway, and a tape gateway. Each of these models can be deployed either as a virtual machine or as an appliance within an on-premises data center, or as an Amazon machine image within the AWS cloud. So in the file gateway instance, you can access the file gateway through standard storage protocols such as SMB or NFS. And when you write to the file gateway, data gets translated to an object and gets stored durably within the S3 cloud, in the bucket of your choosing. So back to the backup question, like what does this mean for backups? How are people backing up using the file gateway? The first obvious example is they're backing up their file data to AWS, to the file gateway. So they're writing copies of their file data. It's being backed up into the AWS cloud in their S3 bucket. A very common use case as well is for database backups, doing things like Oracle backups or SQL dumps using the file gateway. Just like in on-premises where you might be using a NAS array as your backup target for storing your backup files, you can use the file gateway in a similar way, presenting either SMB or NFS, writing those backup files to the file gateway and having them durably stored within the AWS cloud. So now the other thing that the file gateway provides is a local cache, up to 32 terabytes of cache. So you can provision that cache to have those backup files stored locally, so you can have fast restore on premises from that data that's backed up to the file gateway. For tape gateway is essentially used to replace on-premises tape libraries. It's a VTL product, so if you're familiar with virtual tape library, it looks, smells, feels like a tape array. However, it's all based on software emulation. So you're writing to tapes, you're using the same backup software that you were using when you were writing to your tape array, except this time you're writing to a virtual appliance. Instead of physical tapes, those writes are going to Amazon S3, where they're durably stored. In terms of the backup workflow, you can use the same backup software that you were using to write to those tapes. They all support the virtual the tape gateway. And then you can, in terms of the workflow, you can have the same exact workflow. You can label tapes. The tapes are represented within the software as a virtual tape library, so you can actually physically manage those tapes via the software and eject those tapes into Amazon S3 Glacier when you want to store them for longer-term compliance. The volume gateway presents iSCSI block storage volumes to your on-storage or your on-premises applications. The volume gateway provides either a local cache or full volumes on-premise while also storing copies of your volumes in the AWS cloud. Common way customers use the volume gateway is to leverage its ability to create EBS snapshots. So when you write to the volume gateway, the data gets stored in S3 and can be snapshotted and then restored as a volume in EBS and then can be mounted by an EC2 instance. So this is very practical use case for migrating databases to the cloud, for disaster recovery into the cloud. You copy a volume to the volume gateway, and it gets stored within S3 where you can do a whole bunch of things with it through the utility of the EBS Snapshot functionality. EBS Snapshots themselves, so if you're running databases on EC2, you need point-in-time recovery for those databases, those volumes. You can create volume snapshots with EBS Snapshots. So the snapshots are fully incremental, meaning that only changes to the blocks in the volume are stored. So it saves you money in terms of cost efficiency and space efficiency in storing those backups. Earlier this year, we announced the capability to support multi-volume crash-consistent snapshots on EBS. And what that means is if you have multiple volumes sitting behind a single EC2 instance, you can back those up and restore them as a single operation. Okay? We also just announced a capability last month, about 2 weeks ago, which is called Fast Snapshot Restore. With Fast Snapshot Restore, you can identify which EBS snapshots you want to have in a pre-initialized state. What that means is when you go to restore those snapshots, there's no initialization time. They're already pre-initialized, so you get full provision performance for those snapshots at the time of the restore operation. It's a pretty cool capability just announced. The last one I want to cover for people doing database backups in the cloud. EFS is commonly used. So just like we were talking about with the file gateway for backing up databases on premise, if you're backing up resources within the AWS cloud, you're utilizing backup utilities from some of the common database backup vendors. So people are using it for SAP HANA, Oracle, DB2, very common. And what's nice about EFS for this use case is it presents itself as NFS, a POSIX-compliant file system, so it's easy to write those database backups to EFS. And as soon as you do write to EFS, because EFS writes, every write gets written across 3 availability zones, each with its own independent mount point, you can now access those backup files from any one of 3 availability zones. So for a database administrator who's using a database backup utility, this is the easy button. Right? With EFS, you don't have to provision any storage, you don't have to configure any kind of replication, you don't have to set up HA, it's all there for you. So you set up the file system and you start backing up your databases, and it's just that easy. All right, now we're going to switch gears a little bit. We're going to talk a little about some of our partner-enabled solutions. So AWS has a broad ecosystem of backup and recovery partners. These are everything from some of the most innovative new startups to some of the ISVs who have been in the market for 20 plus years and support, the Fortune 100 type companies. We've partnered with all of them, and we do a lot of great business with all of them. But it's important to understand that there's different architectural models for utilizing our partners that you can employ as a business. And so it's important to understand what's the appropriate model for you and how should I architect that utilizing the AWS cloud. So I'm going to go through a couple of different architectural models and sort of compare and contrast the differences and the value of each. So the first one I want to talk about is just backup from on-premises to AWS. So in this model, you've got your traditional backup model where you're backing up resources within your own data center and you want to leverage AWS for your backups. We've already established that every major backup vendor has built a native connector for Amazon S3, which means they can write directly to S3 as a storage target without any modification. So what's also nice is that most of these backup vendors, they license their software based on the amount of capacity managed. So whether you're writing to local disk or you're writing to S3, it's not going to have any impact on the cost from the ISV for managing those backups, right? So that's key. So, and those backups can be written over a number of different means, AWS Direct Connect, over VPN, or over the internet. And in addition to the native connectors, as we discussed, you can use the storage gateway or even third-party products like VTLs. So in this example, the master server is being run on premises, and AWS is being used to store the backups. Yeah, and as I mentioned, that there's typically no additional incremental licensing fees for that model. All right, so now this is a model. So backup on-premises, remote and branch offices to AWS. So for organizations that have distributed models where they've got lots of branch offices, they don't want to have backup infrastructure in every back office, branch office. So the management complexity of that would be unwieldy. So what they do is they've employed a model like this where you've got a secondary backup server in the AWS cloud. It provides federated management to that backup server from the primary master server within their data center. Okay? So now you can have that backup server in the AWS cloud managing the backups for all of the remote offices, and you can take all the infrastructure out of those offices. So you can have endpoint protection within the offices. All the data is backed up to the cloud. If there's a problem with those remote offices, you can restore that data in the cloud and still have access to it. And you can see as I'm going through these, there's the box on the bottom that talks about the partners that support these different backup architectures. So if they're in this box, it doesn't mean that that's the only architecture they support. It means it's one of the architectures that they support. And these are the partners that are in our APN, the AWS Partner Network, storage competency for backup and recovery. All right, so the next model I want to talk about is SaaS backup from on-premises to AWS. So in this model, you're taking away the complexity of running the backup infrastructure in your on-premises data center. In a SaaS model, the SaaS vendor creates the S3 bucket, does all the configuration of the back-end resources, provides all the connectivity, typically in the form of endpoint software that they use to transport the data to the cloud. All the data transport, as long as the basic transport capabilities of Direct Connect, VPN, or Internet, as long as those are available, they manage that entire process. They provide it to you in a single interface, GUI, and you're able to manage it effectively that way. What's nice about this model as well is because it's a SaaS model, it's all-encompassing, and they offer it on a cloud-based model. So there's no upfront investment. You pay as you go, and you pay for what you use. Okay? We're seeing a lot of activity from our backup partners investing in the protection of AWS resources within the AWS cloud. This model is backing up EC2 instances, but controlling that from an on-premises infrastructure. So if you're an organization that has traditionally backed up on-premises and you want to extend the capabilities into the AWS cloud, but maintain a common control plane or single pane of glass for managing that infrastructure, if you want to have the ability to consolidate reporting across both your AWS and on-premises environments, if you want to be able to create common policies and have those enforced across your on-premises and AWS environment, this may be a great solution for you. So in this model, we've got the backup server managing the remote resources that are within the AWS cloud via APIs. And so that's the way that model's affected. So backing up Amazon EC2 instances with AWS-hosted control. So in this model, everything is encapsulated within the AWS cloud. We're not talking about protecting any on-premises resources. This is all being management and protection of resources within the AWS cloud. So it's a very simple model. Everything happens within the cloud. Typically, it starts with EC2 and EBS resources, and then partners scale out their functionality from there. And you can see there's a number of partners that have already begun supporting this model. So earlier this year in January, we launched a service called AWS Backup. AWS Backup basically is applied to that same sort of configuration where you're backing up a bunch of AWS resources and only AWS resources within the cloud. It's a fully managed service, so it provides a centralization in terms of creating policies that you can apply for the backup operations across multiple AWS services. And you can see the services that we currently support: EBS, EFS, RDS, DynamoDB, and Storage Gateway. And what this does is it provides consistency, so you can create a common policy so the backups are taken across these services in a consistent way. You can roll these out across your organization and manage it centrally so that you can ensure that the backup activities are meeting your compliance objectives as an organization. Seeing great adoption with this. Customers who have built their own scripting and functionality to sort of initiate snapshotting functionality within the AWS cloud for various services that don't want to continue down that path of building on and maintaining those scripts have flocked in droves to this service. So seeing a lot of good reactions from the service and the outcome from customers. And so people say, hey, well, wait a minute, you just talked about all your backup partners and AWS Backup, isn't it competitive? We don't view it as competitive at all. We view it as complementary to our APN backup partners. And the reason for that is because we're making it open and available. So with AWS Backup, we've created a set of APIs that our partners can write to, which gives them an integration point. An integration point that allows them to write to a single set of APIs, but have access to all the underlying services that AWS Backup supports as a service. So great example of that is EFS. So AWS Backup supports EFS. EFS had not had its own native data protection capabilities prior to AWS Backup coming online. Now we have partners who are building support for EFS through the AWS Backup APIs. All right, so I want to switch gears here a little bit. I want to talk from a customer perspective, and I've got Creighton Swank here, who's a cloud architect at Caterpillar. Creighton's going to talk to us about his journey and Caterpillar's journey in modernizing their backup activities for his organization. So Creighton, thank you.
Thank you. Thank you, Jody. Good afternoon, reInvent. My name's Creighton Swank. I'm a cloud architect for Caterpillar. We're about a little over 3 years into our AWS journey. My team focuses primarily on AWS, sort of soup to nuts. So we do operations, consulting internally, as well as architecture. We work with a lot of the independent teams internally to kind of enable connectivity and expose our services to customers inside of Caterpillar. So a little bit about Cat before I dive into the meat. We are the world's largest manufacturer of construction and mining equipment. We make diesel engines, we make natural gas turbines, we also make diesel electric locomotives. We do business under a number of brands as well. We're a Fortune 65 company. We have 4 million machines in the field around the world today, and we have plans to connect 1 million of them by the end of this year, which I hope we're well on task for. So let's talk a little bit about who my team's customers are, or who we enable inside of Caterpillar. So we have internal customer groups within Caterpillar Corporate. So these are groups like engineering and marketing. So we do a lot of design, as well as kind of public web service hosting, things of that nature. We also have external brands. So there's a number of other brands that are kind of under the Caterpillar umbrella that do business throughout the world, and we work with these teams as well. So some of those brands are Solar Turbines, Cat Financial, Perkins Engines. I encourage you to visit our website if you want to see the complete list of brands. You'll probably see some of those that you didn't know were associated with Caterpillar. So, starting a backup presentation with a bold quote: nobody cares about backups. They're expensive. They affect performance. Why do we have to replicate the backups somewhere else? They're already expensive. My database doesn't support this. So the bottom line is backups are an insurance policy. Jody alluded to this earlier. We pay our bills, our insurance bills every month. We hope we never have to use it. But everyone cares about restores. So when the data's gone, the questions shift. How long until my restore is done? I don't care what it costs. I just need the data. Why can't you only go back to last night's backup? Now, these drive to the concepts that Jody was talking about earlier. Defining RPOs and RTOs is part of what my team does as we work with customers. So we try and work with them to balance cost. Not only cost of losing data, but also the cost of implementing the backup solution. So if we're down and it costs $10,000, but the backup solution to enable that, to protect us from that loss of data, costs $1 million, it doesn't make sense. So what's the problem with backups? Now, talking primarily about the traditional sort of on-premise backups in this particular case. So they're expensive initial costs, really high barrier to entry. So you've got to go buy the licenses or the appliances or media, tapes or drives. And you're not just backing up the current copy of the data, you also have to keep changes. So you're talking about retaining data change over a period of, let's say, 30 days. So it's not just doubling your storage cost. In some cases, it's much, much larger than that. The other problem is when you have shared workloads. You're not separating these workloads. So if you have a unique set of RPOs and RTOs based on these workloads, you kind of have to come up with a common denominator and treat everything like one. So categorizing backup and recovery requirements, it's hard. Nobody wants to lose any data. So if you go to a customer and you say, how much data can you lose and how quickly do you need to be up? They're going to say 0 and right now. So what we have to do is kind of track that and put it towards, here's the cost of enabling that, so we can make financial decisions. And these loosely defined RPO and RTOs, it's just a challenge because nobody really understands what they want, and everybody wants everything, so you kind of have to go and work with them to define, how much can you really get? What business process does this support? Are there manual workarounds? You really have to get to know the workload. I like how consistency moves in slow. That's the other challenge. So if you take a VM-based or a host-based backup of a server running a database, well, when you go to restore that, it's probably not going to work. So what you end up with is kind of a one-size-fits-all solution. And that's really not what we're about in AWS. So when we back up resources in AWS, how do we do it? Well, first of all, we realize there's no one-size-fits-all solution. That's kind of table stakes. So each of the services that AWS offers has an independent backup strategy. And as my team works to enable that specific service within AWS, we also work to define the backup capabilities and what options we can present to our customers in terms of frequency of backups as well as consistency. So each service has to be handled differently. We leverage these native capabilities when they make sense. So cross-region replication with S3, or RDS multi-region replication, RDS snapshots, point-in-time recovery. These are all things that we have to take into account. I'm not going to get access to the VM to install a backup agent on an RDS instance, so we have to get flexible. Automating backups. Jody made a really good point about Backup Manager. This is something that my team has to kind of look into in the next quarter, because we're one of those customers that kind of did it ourselves. We have Lambda functions that go and initiate EBS snapshots based on tags, and we have Lambda functions that go and delete the tags after a predefined, or delete the backups after a predefined recovery retention window. But we control it all with tags, and we allow our customers to select those tags. So when we go through to deploy those resources, they have options. Now, third-party tools, also important, and this is kind of what's going to give us the ability to back up on-premise workloads to the cloud. So partner solutions such as Druva are a really good opportunity here for us to kind of break out of simply our AWS environment and kind of move into the on-premise data center. And the focus on that's going to be specifically the remote offices that Jody mentioned earlier. So we control backups with tags. So we integrate those tags with a template, and those templates are accepting parameters. So what you see here is a real simple example in the CloudFormation template. Do you need a backup of your instance? Yes or no? That's not what our customer sees. That's the code behind it. Our customer sees that box on the right. Backup. Yes or no? Each one of those parameters can be presented through Service Catalog or through CloudFormation deployments. It's just as easy. So think about it also including like retention time or backup frequency or backup window. We're really about empowering our customers to make the choices to find their best times, as well as to find the solution that meets their needs. So we present these things through Service Catalog, and we have a tagging structure. Backup frequency, yes or no. Window, retention period. These are all pretty much the standard tags. Now, these things are nice because we can add tags. If we come up with a new capability, or if things kind of open up, Or we want to leverage Backup Manager. Instead of this, it could be pick your backup plan. Some of our lessons learned. These are things that we learned the hard way. So if you're using a custom tool to take EBS snapshots, and in this space, even Lambda automation kind of follows this, make sure you have one that removes them too. That's important. I mean, only if you don't like money, I guess, but those things do add up. And if you're using S3 versioning or replication, make sure you have lifecycle policies that purge the old versions after your desired retention time. Now that applies both the source and the destination buckets as well. So from our perspective, it's really about empowering our customers running in AWS to kind of take control of their own backups. If you have ephemeral workloads that are auto-scaling, you don't need to back those up. But you do need to back up the persistent store. If that's RDS or if that's S3, go there. Back it up there. I encourage you guys to look into Backup Manager as well, because we have done a lot of undifferentiated heavy lifting to build the automation to back up our EC2 instances, and now the service sort of takes care of it for you. So with that, I'm going to turn it back over to Jody.
All right, thanks, Craig.
Thank you.
Yeah, good stuff. I always like hearing about the lessons learned and the stuff that you can't readily get, but you hear a customer talking about it. It's always so insightful and interesting. So thank you for that. All right, so now we're going to change focus to talk specifically about DR. We think about DR, so business continuance, the operationalizing of a process for getting a business back online after an event. At AWS, we define disaster recovery as the operationalizing of the systems that are needed to get the business back online. So every business has some event that they need to plan for. There's some disruption that's potentially going to take place. And a disaster, as we define it, can be any event that has a negative impact on an organization's ability to conduct business or impact its reputation. So these disruptions can come from a number of different resources. Of course, natural disasters is one of them. I happen to live in California. It's a not-so-natural disaster. So if you've been watching the news over the past couple of years, there's been lots and lots of wildfires in California. As a result of the wildfires, PG&E, who's the public utility in California, they've instituted these brownouts, where they basically shut down high-powered electrical transmission lines when there's conditions that are conducive to fires breaking out. The reason is because the lines swing, they create arcs, and they can start fires. So these are non-natural disasters that this affects thousands and thousands of businesses across California, and there's not a whole lot of warning in terms of when they're going to institute these brownouts. So those are the kind of events that take place. Then, of course, there's the rogue actors, both external threats and internal threats that could potentially harm your business. So now all these things are, they're not items that you can solve, but you absolutely have to plan for, right? You have to plan for your business as the ambassadors for your business and managing risk. And the reality is that many of us have not made appropriate DR plans. So IDC estimates half of businesses would not survive a disaster, particularly due to the fact that over half of the applications are not protected. That's crazy, right? But it's reality. I'm on calls frequently with customers who are large, well-established organizations that don't have DR plans in place and are mandated that they need to get some DR planning in place to support both applications that are running within the AWS cloud, but also applications that are running within their on-premises data centers. So this is a real fact. Hopefully none of you are part of that 48%. But so if you're thinking about doing DR in the cloud, what are some of the benefits of utilizing the cloud for DR? Well, the first and most obvious thing is cost. And cost is significant. So if you're running a secondary site for DR purposes, there's the cost just of the facility itself, the power, cooling, keeping the lights on. That's a substantial cost that you don't have if you're moving to the cloud. But then there's also all the infrastructure required. which, by the way, you have to provision for peak capacity in order to support the failover of your applications to the capacity that are required to keep your business running. That's a substantial investment, and all the management and overhead in making sure that those systems are up to date and online and available for that failover event to occur. If you contrast that with building in the cloud, there's no upfront initial investment, right? You only pay for right-sized compute and storage when you actually need it. So what that means is you can scale down your disaster recovery environment and then scale it up as you need to when a disaster actually occurs. That's for cost optimization. There's lower IT management overhead. There's more opportunities for automation. It's easier to do repeatable testing of that failover event. And you can get systems up in minutes. So the cost benefits, but also the agility benefits of having a DR strategy that includes the cloud are significant. So at AWS, we have this framework for the different models that we can employ to support DR in the cloud. The first one we've kind of already talked about, backup and restore. With backup and restore, you have a backup copy of your data that you would use for restore. But since none of your systems are on standby, this method, while cheap, can be time-consuming, as it would require you to stand up all the ancillary services and capabilities to support that application running live for your customers. So the advantage of that is it's less expensive, very cheap. As we start going from backup and restore and scaling right across the spectrum, Pilot Light, where we increase costs and complexity slightly, but provide more aggressive RPO and RTO, to warm standby, which is a scaled-down version of your existing environment, to multi-site, or hot standby, which is a replica of your existing environment, so you're actually doing load balancing across two environments. So as you go across that spectrum, you're going to get lower and lower RPOs. You're going to get higher and higher costs and complexity. So let's talk a little more detail about these different models, starting with Pilot Light. So the Pilot Light option consists of your environment's most critical elements running in the AWS cloud. So systems are either in standby or powered off state, and data is replicated from your on-premises data center, or it could be another instance within the cloud, I guess, but from your on-premises data center in this example to the AWS cloud. I've got my database server replicating the data. I've got all the application servers and web servers basically configured. I've used CloudFormation to pre-provision the configurations of those instances so that when I need to invoke them and there is an event, I can quickly stand up those instances and minimize my recovery time objective. So when we have that failure event occur, there are a few operations I need to run. I need to initiate the application servers. I need to initiate the web servers. If there's any load balancers that I need to provision, this is when I would do that. Then I need to mount the data volume and reconfigure DNS to direct traffic to the AWS cloud as the failover site. So when you're running, I can't stress this enough, if you're running the Pilot Light model, pre-configuration is your friend. Making sure that your Pilot Light system is updated, making sure that all the systems that you need to support that recovery mode are pre-configured as CloudFormation templates that you could scale up quickly and easily in the event of a failure. So the next model is warm standby. So a warm standby solution maintains a scaled-down version of your fully functional environment, always running within the cloud. So this is more robust than the Pilot Light because you've got systems that are always active. And it's typical in this type of architecture to use a scaled-down version of the resources that you need. So for example, if you need certain types of EC2 instances to support the transaction workload that you have, you can use scaled-down versions of those EC2 instances to economize for cost. So in this instance, when in a recovery event, you can add additional capacity under those under the load balancer. So you can add the quantity of EC2 instances. You can change the type of EC2 instances in order to support the transaction volume that you have. In this instance, I've also reconfigured DNS record to reroute the traffic to the AWS site. And then since you're running the active resources within AWS, again, you're going to have a shorter recovery time because all these resources are already running, but it is going to be slightly higher in cost. And then the hot site. So a hot site represents an active-active configuration in both your AWS and on-premises infrastructure. And this is the architecture you want to employ if you have very low RPO and RTO objectives. For this architecture, I've got a mirrored database server. So I've got, it's going both ways, so it's bidirectional, so the data is in sync constantly. And then the data replication method that you use, by the way, is going to be predicated on the RPO requirements for this particular configuration. But since this is a fully operational model, customers that have businesses that are seasonal, for example, they have large fluctuations, can employ this type of model to absorb the fluctuations in demand that they have. But since the load is being split between both sites, if I have a failure event, traffic's automatically going to be redirected to to the secondary site. And then you can use auto-scaling and pre-provisioned resources in order to scale that environment to meet the capacity requirements based on triggers that you set within your AWS configuration. And so in this model, you're fully prepared for a disaster recovery event because you've architected your application to support that type of event, right? So Cloud Indoor is a leading provider of data migration and disaster recovery solutions. It was acquired by AWS earlier this year. Cloud Indoor simplifies and reduces the cost of cloud-based disaster recovery by offering lots of automation. So a few things, core things that it does that are really interesting. So with Cloud Indoor, you can deploy an agent on your primary application servers. That agent provides block-level replication to AWS, and that block-level replication can support both the applications themselves and all the associated configuration data and files associated with the state of that application. It then uses machine conversion technology to look at the source resources that the application is running on and build an equivalent destination resource within the AWS cloud. This is really cool. And it takes it that one step further. Not only does it build the destination resource, it also builds a scaled down version of that resource and creates a staging environment where you can replicate the data of the staging environment, have it live within the AWS cloud, but then you have a mapping of the ultimate resource that you're going to expand to on a failure event. So it's pretty cool technology, right? So in a failover event, Cloud Indoor's orchestration engine automatically launches fully operational workloads in the target AWS region at the time of the failover. And this process includes cloning disks from the staging area to the target area. And this entire orchestration process typically takes minutes of time and is predicated on the amount of time it takes for those resources to boot up. So while the data is staged, you're incurring costs at a much lower rate, which provides great economics in terms of this overall solution. All right, so now I'd like to bring Juan Mejia from Bank United up to the stage. Bank United's been working over the last year on a re-architecture of their disaster recovery strategy, and so Juan's going to take us through that process and share some insights. There you go, Juan. Thank you.
Thank you very much. Hello, everyone. I work with Bank United. Bank United is a financial institution located in South Florida with $33 billion in assets. My name is Juan Mejia. I'm the data center manager. I've been at Bank United for 18 years, 24 years in IT. I manage the storage, hypervisor, and IT business continuity for the bank. Sorry, wrong one. I'm going to be speaking on the pre-DR modernization architecture challenges and objectives. This is so prior to DR, our prior DR architecture, we have two physical data centers, one in Miami Lakes, Florida, and one in Long Island, New York. Multiple forms of methods of replication. We have vSphere, storage array replication, and database replication. No, it's
the arrow button. There you go. That's the one.
Ah, that's it. Perfect. Thank you. Sorry, guys. We have high-touch failover, documented manual procedures, high complexity, requires heightened levels of coordination between the business and IT. The primary challenges to the bank's data center topology are as follows. Environmental prone to hurricanes and flooding. Geographical, physical locations situated in direct flight paths and close to major highways. Facilities requiring additional investment such as power HVAC to support ongoing DR operations. When Bank United decided to move to the DR facilities to the cloud, the bank was working to understand the following objectives. Scalability, ability to increase resources accordingly in order to meet customer and business demands. Elasticity, enable resources to be made available when needed and only as long as needed in order to meet demand. Resiliency, increase the availability and the survivability of the bank's technology estate. Efficiency, enable the bank to realize objectives without incurring significant idle costs. And enablement, help enable the bank's digital transformation. Pre-DR modernization questions and solutions. Securely transport data to AWS. Being a bank, we have heavy compliance requirements, so we had to make sure a solution provided encryption in transit and at rest. Keep the data sync once the initial seeding is complete. We looked for a solution that can give us enterprise-level replication with minimal dependencies to achieve this. Avoid paying for unused compute on top of the required storage. We wanted to continue to have the same capacity as our current DR and not continue to pay for the expensive storage and infrastructure, also giving us the benefit of pay-as-you-go. Address multiple replication use cases. We were using multiple replication methods, such as storage, SQL replication, Oracle Data Guard, and each of these were managed by different personnel. Provision resources once a DR event has been enacted. Our DR design was expensive since we purchased additional equipment identical to what we have in production. Sorry. Recover from hypervisor different than EC2. Moving to AWS, we needed a tool to replicate and orchestrate a recovery on a different hypervisor. We're currently using VMware, and we had to move into an EC2 framework. Securely transport data to AWS. We use Direct Connect and Cloud Indoor encryption, which provided us AES 256 encryption in transport, and also provided encryption at rest. Keep data in sync once the initial seeding is complete. We use block-level replication and avoid paying for unused compute on top of the required storage. So we're replicating to low-cost storage on AWS, and when we're ready to deploy our workloads, we provision the compute and storage as needed. This removed the purchase of identical equipment and as production, which reduced our DR costs. Address multiple replication use cases. We're replicating at the OS level with a software agent, rather than the hypervisor or SAN, enabling support of any type of source infrastructure. Provision resources once a DR event has been enacted, or an orchestration engine. We automated the deployment of workloads in the target environment by scripting how machines would be provisioned under one console and removed the storage recovery and hypervisor requirements. Require from hypervisor different than EC2, machine conversion technology. We use Cloud Indoor for the hypervisor and OS configuration, boot process changes, and guest agent installation. post-DR modernization architecture. Benefits: automation of disaster recovery. We automated the deployment of servers on AWS by assigning security groups, subnets, instance types, reserved IPs, and tags for DR requirements. Single pane of glass for recovery. We removed the storage, fiber, and hypervisor, thus removing complexity. Snapshots, 48 hours of protection. We protected our environment with the capacity of lowering our RPO and RTOs by leveraging snapshot store and replication. So we snapshot every 10 minutes for 24 hours, and after which we snapshot every hour for 24 hours. This also allows us to roll back every 10 minutes, up to a day if needed, reducing the requirements or removing the requirements for backup restores. What changes in DR testing for Bank United? Remove the need for consistently updating scripts to recover storage and VMs. Remove the dependency on physical hardware. Next steps: migration to the cloud. We successfully completed our DR testing this year, which included over 200 servers. We're now migrating off our on-prem data center with a lift and shift approach. This will eventually evolve to a more native architecture, taking advantage of AWS. In the process of the migration, we're also starting region-to-region replication as workloads now become production. Thank you very much.
All right. Thank you, Juan. Good stuff.
Thank you.
All right. So I wanted to point out some important information about our ecosystem for specifically around DR. So I mentioned our APN partner network and our backup certification. We've also got a DR competency. And you see the ISV partners that we have within the DR competency. Some of these guys have been doing DR solutions for customers for decades, right? Some of them are more enterprising startups. And then we've got on the go-to-market side, on the consulting side, we've got a whole stable of consulting partners who provide DR consulting services to our customers, and all available on our website. So there's great capabilities across the board there to help you operationalize your DR strategy if you need assistance. All right, so wrapping up, just a few final thoughts for you. So using the cloud for backup and disaster recovery provides some compelling benefits. We talked about those. And an integral piece of the cloud is an integral piece of a modern backup and DR architecture. AWS provides services and tools for building reliable backup and DR solutions to support all of your application requirements. And last, AWS has partnered with industry leaders in backup and DR to help mutual customers modernize and operationalize their backup and DR practices. I'd like to thank you all for coming. Please take some time to update the survey and the application. Enjoy reInvent and have a great day.